Now let's take a look at 1.2. All right, so 1.2, it says greatest common factor and least common multiple. This again and again, it is a review from grade 9 or even elementary school. Okay, now here, first of all, these definitions and what is a prime number and what is a composite number. Now, prime number, we all know, it does not have any factors but 1 and itself, means it cannot be divided by anything to get a whole number. Now, the composite number is just, it's basically composite the prime numbers, and you get a composite number, right? So the composite number will have more than 2 factors. Okay, so the prime number, some of the mathematicians are just absolutely fascinated with prime number. And they wanted to see how large is the largest prime number. Of course, there's no largest because number goes on forever. And they also wanted to see, well, now there's a formula, you can write it out to get the next prime number. Oh, they've been trying for centuries. Now, computer has helped with a lot of this stuff. So I think the largest prime number, how many digits do they have? You can Google. It's pretty amazing how large that number is. And that is just a prime number. It has no any other factors besides itself and 1. It's just amazing. Okay, now it says 0 and 1. 0 and 1, they cannot really define them. So they're not prime, and they're not even not the composite either. So 0, 1, they're just on their own. Okay, so then we can see the composite number if they have factors and that composite number. All right, now divisibility. Now this one, you guys are just quickly take a look at by yourself. It's very interesting, divisibility. We'll have done this before. All right, so then let's get down to how to find prime factors. They're just a factor tree, all right? A factor tree, that is always what I use. If you use something else, you're more than welcome. Now, factor tree, always try the smallest prime number, which is divided by 2, if it's an even number, and then go on. And then divided by 3, and divided by 5, divided by 7, divided by 13 or 11, and keep dividing them. Okay, so now we got to greatest common factor. So greatest common factor means if the two numbers together, that means we're going to locate the common factors, and they're the greatest. So now, for example, 36. When we do prime factor tree, then we can see this is 2 to the power 2 multiplied by 3 to the power 2. So just show you quickly what was happening here. So divided by 2 first, then that is 18. Now still can be divided by 2 because even number, then that's 9. And divided by 3, and that's 3. So therefore, it's 2 to the power 2 multiplied by 2 to the 3 power 2. And then the number 48, that's the same thing, 2 to the power 4 multiplied by 3. 60 is this. So 5 is not a common factor because this one has no 5, this one has no 5. And the common factor has a 2 and a 3. But however, the highest power here, the lowest power, as a matter of fact, is 2 to the power 2. And for 3 is 3 to the power 1. And then it's this. And then it multiplied by together is 12. All right? So you're going to find the least number for 2 and 3. Because otherwise, if you say it's 2 to the power 4, this has no 2 to the power 4 here as a factor. This has no 2 to the power 4 as a factor. Right? So if you say this is 3 to the power 2, but this has no 3 to the power 2, there's only one 3 here. Therefore, you pick 3 instead of 3 to the power 2. Now here, you pick 2 to the power 2 because this also has 2 to the power 2 because there's 4 2's here. There are 2 2's here. And then this 2 2's here. Therefore, 2 to the power of 2 is the common one. All right, so you can take a look at the other example or just do the questions. Now, multiple. Multiple means there's a number multiplied by 1, multiplied by 2, multiplied by 3, multiplied by 4. Then that is its multiples. Now, what is the least common multiple? So then, for example, is 15 and 18. You can do this, which is tedious. So 15 and 18. Now, 1 multiplied by 15 is 15, 2 is 30, and then this is 36, and then this is 45. You know, you go on and on and on. In the end, you find, oh, they both could be, they have a 90 as their common. See here, common. Another way to do it is, again, just to use the factor tree. So now, for example, 60 and 72, 60 could write it to 2 to the power 2, 3, and 5, and then 2 to the power 3. And so this one is the highest one. So you got a 5, so you have to include a 5. You have 2, 2, and 3, and 3. And the highest power for 2 is 2 to the power 3. The highest power for 3 is 2, and the 5. You multiply them together is 360. So, called the least, you're looking for the highest. Called the greatest, you're looking for the lowest. Well, then that's about it. Then we finished 1.2.